Hello, everyone. It's Miss Richards here, and I'm going to cover the heart of algebra. And if you remember or you weren't in my sessions, the heart of algebra is about 19 questions on the SAT. So it does change every year, but we talked about 58 total questions, 45 multiple choice, 13 free response, and the heart of algebra, about 19 questions, 33% of the test. And if you broke it down, remember, here we talked about it has a calculator portion and a non-calculator. The calculator portion at 38 question gives you 55 minutes, so you have about a minute and a half per question. And the non-calculator, about 20 questions, you only have about a minute and a quarter per question. So when you go over these, just keep that time limit in your mind. Maybe set a timer um, just to see how long some of these questions are taking you. The SAT is formatted to try to tend to start easy and get harder. So when you do these, my questions are not necessarily in that order, but just, if you know the answers, move on. Don't try to second guess, or, if you think you have the answer, just get to the next problem. So let's look at my section. All right, in the heart of the algebra section, I give you about 25 problems. I'm going to go over 10 of the first answers on video, and then I'll make a second video with the next 10. I think it'll get too long if you try to watch. If you know that the answer's right, you can skip right over. I'm also just going to attach the answer key if you're more a visual person and not an audio person. I try to show my work with everything, so that helps. But if you can read it right off paper and you get it, great. If you need an explanation, then come back to the video for sure. Anywhere that's on here that says NC, then that's a non-calc. So make sure that if it says NC, for example, number 10, that you're not to use a calculator, okay? And so maybe put on a little timer, make sure you're not spending more than, a minute and a quarter. So 60, 20, 80 seconds per question, okay? All right, so what I would suggest is that you try 20 problems. Don't give yourself more than 30 minutes to go through them. And then I would come back to the video and kind of skip through each answer if you need an explanation or you don't. And like I said, I'll get through what I can in a decent amount of time. If it gets too long, I'll stop and I'll start a whole new video for the next section. All right. Problem one is your inverse directly type of problem where k is a constant, y is 24. So you want to do 24 equals k times 6. Solve for k. K is 4. That's not our answer. They want to know what y is when x is 5. So y is 4 times 5, and our answer is 20. Move on. Next one is writing an equation given an expression. 16 plus 4x is, one thing we want to remember is always represents equals. Is 10 more than 14? Well, of course I can write 14 plus 10, but instead I'm just going to write 24. Okay, when we solve this, x comes out to be 2. And what you really want to be careful about is a lot of times when you're speeding through problems, you think that's your answer, x is, and you circle 2. But please read, what is the value of 8x? So just because they throw that in there, that messes a lot of kids up. So a lot of times on problems like this, they are just testing reading as well and paying attention. So just be double as careful that you don't select x is 2, that you keep reading the problem. Our next problem is an absolute value problem. And one thing we want to be careful, absolute value always has its little, things to remember. So for example, one thing we have to remember is the absolute value can never equal a negative number. So when I have plus 1 equals 0, your first move is going to get that 1 out of the way, and we're going to get n minus 1 equals negative 1. Well, one thing we have to think about is it can't, absolute value always has to come out to a positive number. So therefore, there's not going to be any number that I put inside here that after it comes out of the absolute value brackets is going to equal a number, a negative number. Okay. A lot of times with absolute values, you have to remember you got to set it equal to a positive and to the opposite of a negative if you're trying to solve. You got to watch when there's inequalities, making sure you change and have two equations when it's absolute value. Problem 4 has an equation for us, so you want to pay attention. That equation was given to us. It gives you a word problem, talks about relationships, and then it wants which of the following expresses the air temperature in terms of the speed of a sound wave. So one thing is maybe that doesn't make so much sense, but then you start to look at the answers and everything is in T equals. So one good part is I should know that if I have my equation, that I am simply just rearranging this equation to solve for the value of t, which I can tell from the answers. So that saves time instead of trying to guess what variable. I mean, there is only two variables, a and t. But first move, t is attached to that. So we're going to take that 1052 and set it equal to 1.08t. And then we are going to divide by that 1.08. Just making sure in the right order. So here, this is where it's minus, this the 108's on top. So out of these, making sure it's in the correct order and it's a minus sign since we brought it to the other side. This next problem is an inequality, which can sort of be treated like solving just a regular equation. Now, if you're slow at solving equations, one thing might be to try to just simply plug in the answers because you're finding the one that's not a solution. If you are quick at solving equations, then if I can, subtract 3x from this side and add over here, then I can tell this. It is pretty simple that it didn't ask you, what you have to be very picky about is the fact that -2 works. So if I put in -2, it goes in, it will work. So which one's not a solution is any number less than -2. So again, just like absolute value and just like inequalities, you want to double check your solution because a lot of times it's just kind of the answer, but they're trying to get that last little trick out of you. So double pay attention to inequalities and absolute values. All right, number 6 is your typical linear. That is a very straight linear line, has points on it. The points are kind of obvious. Most likely with linear, you're normally always going to be able to get into the form y equals mx plus b. So something to remember, you have to remember m is your slope, b is where you start. So if we looked at this graph, we know that it's starting at 5. So automatically you could take out those pretty easily if we know it needs to be in this form. Okay. And we need to be able to see what C represents. Sorry, I missed the multiple choice first. See what C represents. And that's obviously going to be the initial of renting the boat. So it's $5 to initially rent it, and then what it costs for every hour. So it's basically asking us, is it 75 cents, which is, 3/4, or is it 3 hours? Sorry, 70 quarter, 3/4 of an hour, or is it 3 hours? And so if you could just count, you can count up and over, or you could pull points like 1 and 8 and 2 and 11. And if I pull them and I did slope, it's 11 minus 8 and 2 minus 1. So it's going to be that 3/1. So we know it's C. Okay. Graphs, just try to pay attention to it. Is it linear? Is it exponential? Big differences. if it's linear, we are normally always looking for y equals mx plus b and normally trying to find that rate of change or slope. The next one is an inequality, right? Less than and greater than. You have negative x and you have positive x. But in the directions, it tells you 0, 0 is a solution. So one thing to think about is if I plug in 0 in the top one, I'm going to get 0 less than a. And if I plug in 0, I'm going to get 0 greater than b. So right here, A has to be greater than any value of 0, yet B has to be less than 0. So that's going to tell me that A has to be larger than B. A is in the positives, B is most likely in the negatives. Well, it is in the negatives. So therefore, I know A greater than B. All right, when I see this problem, I see $6.50 for a drink, for salads and drinks for $2. Automatically, I'm going to start thinking a system. The food truck's total salads and drinks was 209. So X plus Y equals 209. And then you have your money in the next equation. So $6.50 for a salad, $2 for a drink equals your money. Now, this is isolated, so you can either use elimination, where I just multiplied the top by 2, probably what I'm going to do here. You could also isolate it and use substitution. You also have the option, if you have a graphing calculator, to get them into y equals and graph them. The problem is your starting points are going to be 209 and 863, so you're going to have to edit the windows, but if you're quick with that, it would stop you from doing any algebra. But this shouldn't take too long. You do have a calculator for this. It's your typical. They just want to make sure that you know how to do it. So I'm subtracting, so they wipe out, and then I'm getting 836.50 minus 418. I'm going to get 418.50, and I'm going to divide. And I'm going to get 93. The only issue is you absolutely want to make sure, are they asking you for salads or are they asking you for drinks? Because remember, we talked X was salads because I made them $6.50 and Y was drinks because I made them $2. So make sure, because a lot of times they will put both answers. Here, X is 93, 209 minus 93 is 116. They don't put both answers, which is kind of nice, but a lot of times they will. So just make sure that you do label your variables, as your Algebra 1 teachers always have told. All right. All right. Not going to lie, number 9's not probably my favorite algebra problem. I just think it's confusing. I think it's just a wording, and they're trying to, just mess you up. Alma bought a laptop at a computer store that gave a 20% off the original price. So if the original price was X and I'm giving you 20% off of that original price, I hope you can see that's 0.8X or 80% of the original once you take it off. The total price she paid the cashier, P in dollars, included an 8% sales tax. So when you pay that, that's your total at 1.08. So for me, the price she paid of something was 1.08 with the sales tax and 20% off the original. And then because it wants it in terms of P, I would just divide by these two. I would put 1.08 on the bottom and 0.x on the bottom. And that's going to be what the price was given. There may be a better way to explain it. I'm not exactly positive of this one. Like I said, I definitely can kind of see they don't necessarily fit in. I would have to pick out of these, but if you're doing the original price and you could guess and test, pick an original price of a computer, $1,000 and put it in and see if it makes more sense. problem. I only have 10 seconds. We're going to factor it to 2x minus 3 and 2x plus 3. And you're going to see that they want to know what could be the value